Hi, what we're going to do now is we're going to have a look at the derivative of some trig functions. So our first one we're going to do is we've got y equals sine x. So we're going to see what the derivative of this is going to look like. So if we look at what our stationary point's at here, remember our derivative provides our rate of change. So at our stationary points, our rate of change is going to be 0. If I look at this point here, it's decreasing at its maximum rate. So my derivative is going to be at its maximum negative value. At this point here, it's increasing at its maximum rate. At this point here, it's increasing at its maximum rate, and so on. So if I connect these points up, I'm going to get a graph that looks like this. Oops. And it continues on. So if you have a look at my new graph, my derivative of dy dx, okay, is now a cosine graph. So if y equals sine x, the derivative is going to be cosine x. So now looking at a cosine graph. So what we have here is y equals cosine x. Remember, it starts at its maximum point, goes down, up and round. So there's our full cycle. Same again, we're going to have a look at what's happening. Here we have our stationary point. So our derivative is at 0. At this point here, it's decreasing at its maximum rate. So our derivative is going to be at its maximum lowest value. At this point here, our derivative once again is 0. At this particular point here, our derivative is increasing at its maximum rate. At this point here, as a derivative, our rate of change is going to be 0. And at this point here, it's now decreasing its maximum rate. So if we look at this, what we have is we have an inverted sine graph, or an inverse sine graph. So our sine graph is flipped. So our derivative, dy dx, is going to be negative sine of x. All our other derivative rules are going to apply, but basically what we know is the derivative of sine x is cos x, the derivative of cos x is negative sine of x.